Please welcome to the stage, Tobias.
Hey everyone, it's my first time at NodeConf, so go easy on me. Yeah, I'm here to talk about something that's not super related to JavaScript as a language, but it is very relevant to Node and a bunch of other runtimes. So yeah, the mandatory 30 seconds about myself. I'm Tobias. I'm currently a researcher at the Vienna University of Technology in Austria. Before that, I was a software engineer, and I've been working on Node since about 2016, 2017. I've been on the TSC, on the Technical Steering Committee for a few years, and I've been doing a bunch of security research for Node, mostly just for fun, like investigating vulnerabilities, fixing vulnerabilities, finding vulnerabilities, and also in a few other projects. So why do we want to talk about that? So my main research isn't exactly related to research, but since a few people here have asked me about it, I thought I'd include one slide to just get that out of the way. So my main research area is logic, which is defined as the study of reasoning. It's somewhere in the intersection between maths and physics, and technically philosophy, even though my research doesn't have much to do with that. So more specifically, my research is about reasoning about the correctness or incorrectness of programs. So those are all very super interesting areas, but security is just one small property, or a significant property, but one of many properties that you may want to formally verify. So we talk about how do we prove that software is correct, how do we prove that it has bugs. So we all use tests, but tests can only ever show you that your program has a bug, right? Tests will never prove that your software is correct. Fuzzing won't prove that it's correct. There is simply no good approach using testing to prove that your software is correct. So we look at a bunch of alternative methods and try to see what would actually work in practice. But yeah, let's transition into security. So why do we want to talk about sandboxing? There's a bunch of reasons, and the most obvious one is you don't necessarily trust code in your Node modules directory as much as you trust your own code. Or if you have a Linux binary that comes with the operating system to change your user password, you probably trust that binary more than if you run npx whatever. So npx, at least, it asks you if it's okay to install the module, but besides that, you've got no control over what code runs on your machine. And the other thing is, even if you trust the code, it might be overtaken by an attacker. So you might have a vulnerability in your own code that you think you can trust, and then again, Node modules, who knows what's in there? You have no idea. And so if that code ever turns malicious, you want to limit the impact of that malicious code. You want to make sure it doesn't do anything that would be too horrific. And the last thing is, of course, you don't want complexity. The main enemy of security is complexity. A simple system is usually more secure than a complex system. And if a code has access to fewer resources, there's fewer things it can do, so it tends to be less complex. So that's kind of the motivation behind this. And a keyword that's brought up a lot in this area is the principle of least authority, or called principle of least privilege. Is a very intuitive concept. Ideally, if your code is supposed to do one task, it should only have the privileges required to fulfill that task. If you're writing a file system tool or so, it shouldn't necessarily have access to the network, right? That's a very intuitive concept, and some software implements it well, even hardware implements it well. So an Intel processor, for example, has 4 levels of trust, and the kernel can decide what level of trust is associated with any code that is executed. Node, of course, always runs in the lowest level of trust on an Intel processor. That's just by design. And device drivers are somewhere in between. The operating system also does a great job at this. It gives you processes, it gives you user IDs. Modern Linux has a bunch of security features that allow you to apply this principle with a ton of granularity. You can really narrow down what resources you want to give access to and whatnot. Browsers also do a great job. Browsers also, when you have JavaScript code in a browser, it doesn't automatically get access to any resources on your system unless you explicitly opt in for like GPS or your file system or so. Node, on the other hand, wasn't really designed with this in mind. Node was designed to give JavaScript access to the system just like any other process on the system. That was the whole idea. So it's not exactly Node's fault that it's kind of difficult to sandbox, because the whole idea, again, was to give access to the system to JavaScript code. And it's not exactly a new thing either. Sandboxing is literally everywhere. There's a ton of sandboxing happening in every component in your system, whether it's in the hardware, in the operating system, in Node.js, in V8, in your JavaScript code. So there are so many layers to this that it's kind of difficult to decide what layer you want to focus on. And yeah, it leads to this anti-cycle where there's difficulties connecting your components, so you make more connections, and then you figure out, oh wait, this is not great for security, so let's kind of restrict stuff, and yeah. It's just a cycle that keeps on happening, and people keep reinventing ways to sandbox stuff. So in this talk, we're going to try to see how people sandbox stuff and how it compares, and what actually works for Node applications. So first, we have to kind of figure out where do we want to put the sandbox. So of course, you have your application, which is JavaScript, WebAssembly, maybe some native add-ons. Of course, a bunch of dependencies is not just your own code. NPM estimates that about 3% of an average Node application is written by the actual author of the application, and 97% is dependencies. So yeah, this circle is 97% code that you did not write. It's 3% that you wrote. Around that, you have the Node runtime and a bunch of stuff that comes with it, libuv, v8, and all those kind of impose some sandboxing restrictions, but to various degrees. Around that, you have a process that's kind of supplied by the operating system, and Node might not even be the only thing running that process. If you have Electron, for example, to be fair, it splits up your runtime into multiple processes, but in a way, it also runs Chromium in the same thing, and so Node might just be one embedded component in this process. Around that, you've got the operating system, which again imposes sandboxing on the process, and yeah, it's a lot of steps here, and there's sandboxing at every level. And around that, the hardware, again, also provides security features. So yeah, not an easy design. Let's talk about your application, assuming it's written mostly in JavaScript first. We don't want to focus on that, but it's still something that's brought up a lot. So you have your application, of course. Maybe it's trustworthy. I don't know what kind of code you guys write, but let's assume it's somewhat trustworthy, the application that you write. But it could still have vulnerabilities. So if an attacker is able to execute code in the context of your application, suddenly they gain the same privileges as your application. And then also your dependencies, again, you haven't read the code. You don't know what's going on there. You don't want that to have all the privileges on your system. Then Node modules are also, for various reasons, written in JavaScript, at least partially. So user code can interfere with built-in Node modules in many ways, and that's an ongoing debate if that should be allowed or not. And there's good arguments on both sides, so I'm not going to come to a conclusion in this talk. But yeah, it's very easy to interfere with Node internals through JavaScript. And then lastly, and that's kind of the motivation for a lot of the efforts in the sandboxing JavaScript space, many people want to execute untrusted JavaScript code as part of their application process. The user might give you some code that they want to run, like some filter function, some mapping function or so, if you have database queries or so. And none of these concepts here, neither Node VM nor function or eval, obviously not eval, are security mechanisms. None of these provide any security guarantees, so don't do that. But what people have done is various approaches. Node has a feature that's called policies. It's experimental still, and it kind of limits what code you can load and run. And then there's various proposals to GC39 that are being considered. There's Shadow Realm that a lot of you might have heard of. It's been implemented in a bunch of runtimes. It's stage 3, but I've been told it's just being demoted to stage 2 again due to reasons. And then there's compartments, which is very similar, but a slightly more complicated mechanism. And that comes from Mark Miller's secure ECMAScript, that's also known as hardened JavaScript. And that actually provides strong security guarantees under a ton of assumptions. So you can write very isolated code with a ton of security guarantees if you make no mistakes. So it gives you a nice foundation, but it's still complicated to actually achieve the security goals that you have using only secure ECMAScript. And then there's Lava Mode, which is a cool project, which uses secure ECMAScript to essentially every single NPM dependency, every package that you use runs in its own compartment. It can only interfere with your other code to some degree. And you can restrict what access it has. For example, you can also restrict whether the code is accessed to the file system or not, and all that. So this is not what we want to focus on in this talk, but it's still important to mention that within JavaScript, within this innermost circle, you can definitely do sandboxing. And it is very useful to do so, even though it can be quite the overhead. Not just performance, also just writing code in that way. So what we want to focus on in this talk is more isolating the runtime itself. That affects Node, browsers, Cloudflare workers, Deno, Bun. So any JavaScript runtime kind of wants to have a better mechanism than just within JavaScript. That's for various reasons. So why is it not enough to just do the sandboxing in JavaScript? First of all, the sandboxing mechanism might have bugs or so. V8 might have a bug in its JavaScript implementation and suddenly your entire sandbox falls apart. Also, there's Node native add-ons. So if you load any C or C++ or Rust or Go or whatever compiled code through a Node native add-on, the JavaScript sandbox has no way of restricting any of that. So as soon as you use any NPM dependency that has a compiled native add-on that it's loading at runtime, all your security guarantees fall apart. Same thing happens if you use child processes or so. There's no way for a JavaScript sandbox to restrict what a child process can do. And you can't say, okay, I trust the ls binary or so, because there's a bunch of ways of injecting code into any Linux binary that's not, well, under certain assumptions. So all of that falls apart. Also, Brian had the great presentation on the FFI proposal, and there he is. And all that is going to bypass any JavaScript security mechanism directly. And yeah, that's why it's not enough to implement sandboxes within JavaScript, and that's why we need to kind of consider more. So let's have a look back, before 2000, probably long before I was born. So these security mechanisms kind of became somewhat obsolete around 1999, shortly after I was born. So yeah, this problem that we're discussing is not new. For example, Apache and Nginx, they traditionally needed root access to be able to bind to port 80 and 443. The same for an email server. So any ports you want to bind to below 1024 on Linux by default need root permission or now capabilities to be able to bind to that port. But you definitely don't want to run a web server, especially one that's running PHP or so, with root permissions. You never want an attacker that exploits some PHP quirk to somehow gain root access to your web server. And so the approach that people figured out and that works super well is you start the process as the root user, then you call bind, a system call that allows you to bind to that port, and once that's done, it's done. You have the file descriptor for the socket is bound to a port. After that, you call setuid to drop your own privileges, your own permissions as far as possible. So Apache usually had a www data user or so that it would set UID to. And there was no way, even if you took over the entire process somehow, there was no way for you to restore root permissions once that was done. And only once that was done, once Apache or Nginx or whatever had dropped its privileges as much as possible, only then would it start accepting connections from the outside. So at the time it was communicating with the evil internet, there was already very few privileges. Even if the entire process was being taken over, there's very little that an attacker could do with that. So things have changed a little. Again, since 1999, Linux has capabilities, so you don't even need root access anymore. But the core idea is still present in a lot of applications today. Essentially, you start with the privileges that you need for the initialization, you allocate a few resources that you need those permissions for, then you voluntarily give up your permissions of your own process, and then you start interacting with any unsafe components, like the internet, NPM packages, user code, anything you don't trust. So it doesn't solve all the problems, but it helps a lot. It reduces in most threat models, it helps a ton. So that was the old way. Let's look at a few cooler new features. So this is kind of low level, so I don't mind if you want to skip this part, but I think it's super interesting. So modern kernel feature, for example, is seccomp, and it's often combined with Berkeley packet filters, BPF. And combined, you can create a super powerful mechanism for filtering any syscalls that your process does. So for your process to be able to interact with the kernel, it has to perform syscalls, which are implemented through interrupts, and the kernel intercepts those interrupts and then performs a function call or so in response to that. Now with seccomp, you can install a policy for your own process that defines how to handle those system calls. And you can do so quite flexibly. So one approach that's quite common is you forbid for your own process any way of opening new file descriptors. So that sounds ridiculous at first, because then your process will never be able to open any more files, but we'll see later why that's not a problem. So in this example, for example, we forbid forking, so you can't spawn any new processes. We forbid opening files. There's a bunch of other system calls that you have to forbid for that, because there's a few variations of the open system call. But yeah, we still allow writing and reading to and from existing file descriptors. We just don't allow opening any new ones. And this mechanism is incredibly powerful, because once you've installed this policy, you can prevent any future changes to the policy. So once you've installed this in your own process, even if an attacker fully takes over the process, there's no way they will ever be able to open any new files. And now combining that with a bunch of other new Linux features like namespaces, two runtimes, Chromium and Cloudflare Workers, have come up with a really nice security concept that works super well for sandboxing. Essentially, you have one supervisor process, and after that has done its initialization, some whatever loading, it spawns an application process that runs concurrently. The application process also does some initialization, as usual, and then these two processes establish some IPC channels, some inter-process communication that allows them to communicate, and that will remain. No matter what the application process does now, besides closing that channel, it will still be able to communicate over that channel. So what the application process then does is it drops all of its privileges except for the ability well, a few important syscalls, and then the ability to talk over that IPC channel. Everything else it just discards from itself, and it will never be able to regain those permissions. And then the only process, the only component here that runs any untrusted code is the application process. So again, even if the entire application process was somehow taken over by a malicious dependency, by some remote code injection or so, I mean, Cloudflare Workers obviously has to have a very tight security model because they run entirely untrusted code, and Chromium essentially as well, because any JavaScript code in your browser you don't want to trust. But even if you take over the entire application process, there's nothing you can do besides talk to the supervisor. So when the browser, for example, or if in Cloudflare Workers you want to open a file or so, well, Cloudflare Workers doesn't do that, but let's say you want to access any critical resource, you can't do that from the process directly. You have to ask the supervisor to do that for you. You ask the supervisor process to do that through the IPC channel. The supervisor checks the request against the security policy and then either rejects or approves the action and sends the result of the operation back to the application process. So this model is great because there's absolutely no way for the supervisor process to ever run any untrusted code. At the same time, the supervisor process is the only process that has access to critical resources. So this works very well. It's very similar to the old Apache model, where you voluntarily give up your resources after you've established whatever resources you need. But the problem is it doesn't really work for Node. Node was built on the assumption that one node, well, let's ignore cluster also, but Node was built on the assumption that there's one process for one node application. And if we were to change that model now, it would break a ton of stuff. So this unfortunately isn't realistic. It also still wouldn't work with child processes and with native add-ons and FFI. So this doesn't solve all our problems. It's just a very cool approach for some runtimes that works very well. We could redesign Node in this way. It would break stuff, but it would provide strong security guarantees. So then there's what Node and Dino have been doing instead, and it's a good idea, is to have a permission model that's implemented in the process. And of course, that is very different from relying on kernel features for your security. You suddenly have to implement all the security checks yourself. You have to provide the security guarantees. And it's portable. That's the main benefit here, or from my point of view at least, because none of the features I've talked about for the last 10 minutes work on Windows. It's no surprise, but yeah, try implementing a sandbox on Windows. For example, Chromium just provides the SecComp sandbox on Linux, which is great, but yeah. It also, unfortunately, is too high level to really know what the system resources are. The permission model in Dino and Node can only operate based on paths, for example, when you talk about the file system. And Raphael has given a great talk on the permission model yesterday, and he mentioned that symlinks, for example, symbolic links, are a huge issue because, well, at least they can be a potential issue because the node can't really know where those symlinks point to without resolving them, and if you do that, you break a bunch of stuff. So if we don't want to break things, then it's kind of, we have to conclude towards some limitations that we have to accept. And it also is incompatible with native add-ons, child processes, FFI, OpenSSL engines, and the inspector module, because all those would allow you to bypass this security mechanism in some way. Some of that is fixable through a ton of work, and I know that Raphael has been putting in a ton of work here. And this model was designed by some amazing people, Raphael, Anna, James, I'm probably forgetting someone. So a ton of engineering work went into this. And it's just by design that Node, unfortunately, wasn't designed this way. Dino made a few other choices. Dino has a few APIs that are designed in a way that incorporate permissions in a very intuitive manner. But Node, unfortunately, wasn't designed this way. So without breaking stuff, there's very little one can do here. So the last thing I want to talk about briefly is what I call on-the-fly sandboxing. We've heard now that the Linux kernel has a ton of, or most modern operating systems, I should say, with the exception of Windows perhaps, have a ton of features that are great at isolating processes. You have so many things that Docker isn't built on magic. It's just using a few kernel mechanisms in a very clever way. We don't want what Docker does. I mean, a container is great for production, but it doesn't solve the issues in your development environment. You are at some point going to transfer your credentials inside the container, so if you try developing in one. So it doesn't really solve all the issues that you have. But the core idea is not bad. And Google realized that, or maybe Miniger even predates that, I don't know. It's a very nice tool and library that you can use to isolate Linux processes that is used, or it used to be used on Android and is now still being used in Chromium OS, for example. And it uses these kernel features in a very clever way to isolate processes with very strong security guarantees. It uses a ton of features. Namespaces allow you to you can have multiple sets of users on Linux. I don't know how many of you knew that, but you have like your set of users that you interact with, and then you can on the fly create new user accounts that only exist while some process is active or so. You can create new mount namespaces, so you can completely change the view that a process has of the file system. And all of it works in the user space. You only have to interact with the kernel in very few places. And yeah, so this is compatible with a ton of stuff that Node already does. For example, child processes aren't an issue. All of this is enforced by the kernel. Node doesn't have to care about these security guarantees at all. Node is just running within the sandbox. And you need a ton of configuration, of course, whatever sandboxing approach you take. But this is a somewhat reliable one that is compatible with a lot of existing Node applications. And before I run out of time, let's, as Matteo phrased it, hope that the demo gods are with me. So if you have any critical resource on your system, let's assume, for example, that I want to see if the user has any SSH keys installed. I don't want to disclose them here. So yeah, there's 11 files in my SSH directory. Now, that's not great if an attacker, if an NPM dependency could access all my SSH keys, even though they are usually encrypted. So I wrote a small configuration that's called untrusted. And if I just preface a command with that, it says there's no such file directory. So just by prefacing the command, this on-the-fly isolation, suddenly the process thinks that the directory doesn't exist anymore. Similarly, thank you. Similarly, when you run Node without anything, it can access whatever it wants on the file system, right? If you run Node with the experimental permission flag, it will give you a warning when you start it up that it can't access the history file for the REPL anymore, which makes sense. You haven't given it permission to access the file system, so the REPL can't access it anymore. So the way that the sandbox works is a bit different. If you run it in untrusted, it will have access to the REPL file because it won't be the actual REPL file in your home directory, but it will emulate a home directory for you and kind of quarantine whatever the process writes into it. So Node works fine with that. But you can also say you want a frozen environment, and suddenly Node is going to complain again that it can't access the REPL file again. It's a different warning this time because Node isn't aware of the sandbox. So from Node's point of view, it's just an error. But yeah, this works super well. And it also works with, let's do some, I don't know any npx commands that just display text besides this. So npx, for example, also just works within the sandbox. But if I now, let's do something risky, let's invoke a command that will delete my entire desktop, and there's a ton of stuff in there. So let's hope I implemented this tool during a talk yesterday. So I hope I didn't make any mistakes. It's installing dependencies. Let's see what if my directory is still there. Yes, it's still there. It contains 23 files. So yeah, this is one more approach that we have for sandboxing applications, at least on Linux. I'm no Windows expert. I assume there's some mechanism to make it work on Windows, but I'm never going to do that. So yeah, I hope your main takeaway from this is whenever possible, trust the kernel for any security. You have to trust it anyway, otherwise what's the point? So if any of these mechanisms help you in any way, use them. Thank you.
Thank you so much, Tobias. The bravest demo I've ever seen. We've got a couple of minutes for questions. Does any? Oh, you missed out last time, so I'll come to you first. I can see Gil's got his hands way up over there, so I'll go there first. Yeah.
Hi, I wasn't sure, but can you restrict based on path? Like read only these files or not these files?
Yes, you can create pretty much whatever you want. You have an entire virtual file system. You can have nested file systems. For example, in this setup here, there's a bunch of nested file systems. The root directory is mapped to a virtual root directory. Then you have a virtual proc file system, a virtual dev file system. Because if you expose the proc file system from your actual system, you can use symlinks to again gain access to other stuff. And the home directory is another virtual file system that's all mapped together. And the landlock module, this one, that is also a relatively new Linux feature that you can use besides mount namespaces to further restrict based on paths. So that is very similar to what the permission model is doing. Whereas mount namespaces actually restrict based on file inodes in the file system. Landlock allows you to restrict based on paths. So yeah, there's a ton of features there that you can use. You just need to create a configuration file.
And all this is in minijail, whatever.
Minijail implements basic utility, but again, it's no magic. You can use the same system calls to implement the feature yourself. And I do think that's something that the ecosystem desperately needs. All these features are there. We just don't have any convenient tools for actually accessing them. So what I hacked together yesterday, nobody should use that. I'm sure there's a ton of issues in there. But all the core features are there. Docker is way too complicated for this use case, and we don't want images. You want to have your own system just with a few security guarantees. But yeah, if someone wants to write some cool tooling for that, I'd be all for that.
Thank you.
Hello. So how realistic you think is to use it in a developer's machine?
Depends on how much effort you want to put into securing your development machine. So all this is a great mechanism, but it has various issues. For example, a major advantage that Node has with the permission model and with policies is that Node actually has insight into what code is running. These sandboxes outside the process, they only see like an npm process and then a Node process or an npm install process or so. So while you can restrict the permissions based on what process is running, for example, you might want to give npm more privileges than an npm install or like a script that the user is running. There's limited insight that the sandbox has into the internals. That's a big issue. The other thing is portability, of course. So for anyone developing on Windows, I have no idea if any of this is ever going to work there. But yeah, realistically, you can achieve some good security guarantees with relatively little effort. For example, if I were just to develop as usual in my terminal and just prefix any npm command with the word untrusted, 99% is still going to work, and I still have the sandbox that prevents any npm scripts from doing something to my actual host machine. It doesn't help much in production, of course.
So I think you might have just answered my question. First of all, amazing talk. So I'll make it quick. So, you know, you started out your talk saying like, okay, well, we should start from a place of zero trust and like, you know, incrementally give trust to things, you know, as opposed to kind of trust by default, right? So like the opposite of the way the internet was architected. Internet was supposed to be open, trusted network, and so that's why security is so hard, right? We're like re-architecting security into a model that was never designed to be like secure. And so I'm trying to understand, like, is it possible for this to just be like default behavior in the next version of Node? And so that like by default, this is how it is, and then you have to explicitly opt out. And like, I'm probably I'm making like TSC members probably cringe right now because it's probably maybe potentially breaking, but it feels like the right way to go. However, like an obstacle that I see for that is the Windows support, right? Like,
yes.
So I'm wondering, are there folks from Microsoft here that are willing to sponsor a team? Because this is like really important stuff. So
I'd be surprised. I do think, I don't think it's reasonable to have that as a default. It's almost impossible. It also cannot really run within the Node process. It kind of has to be an external mechanism. The Node process can constrain itself in many ways, but there are so many ways to interfere with the Node process. It relies on so many environment variables. It relies on so many ways of loading code into the runtime that having a separate sandboxing mechanism, in my opinion, is very reasonable. So I think the way forward, the like short-term way forward at least, is to have external tooling that provides these security guarantees just by prefixing, or you can alias your Node or npm command to run in that sandbox or so. It all works rather well. You run into a few incompatibilities. So top, for example, just displays a list of processes, right? But if I now run untrusted top, it will not be able to see any of the other resources on the system. So there's a few things, and that's good. It's intended as a security mechanism, but it might break a few things. So having it as a default is not really a good way forward, I think. Thank you. That's great.
Oh, there you go. A really exciting and inspiring talk there. Thank you again, Tobias.
Thank you.